So so welcome everyone to this new PyData Madison Meetup. Today is September 24th. I think that we skipped last month because things were kind of, difficult with the COVID situation, and it was just a bit tough just to organize the meeting for last month. But fortunately, this month we have, I don't know how to pronounce your name, Mahdi. Is that okay?
That's fine. That was perfect.
Cool. Who's going to be our presenter today? So Alisa will introduce Mahdi later. But before that, I'm just want to read and remind everyone our code of conduct. As we have mentioned in previous sessions, PyData is part of a non-focused organization. So that means that there are many PyData meetups around the country and in other countries as well. And we are the founders of the PyData in Madison. So our code of conduct, the short version is be kind to others. Do not insult or put down others. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for non-focus. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriated. And basically, the idea of this meeting is create a safe and inclusive space for everyone, regardless of their background. So everyone just please be aware of that and mindful of the effects of our language since we are online. So now I'm just gonna pass the mic to Alisa, who's gonna introduce Mahdi.
Awesome. Thank you so much, Pablo. So we are extremely excited to have Dr. Mahdi Sadjadi with us and to talk about web scraping, which is one of my favorite topics. So I hope all of you are also just as excited as I am about this. Mahdi is currently a data scientist at VideoAmp, and he also earned his PhD in physics at Arizona State University. And he studied disordered systems such as glass to design and understand their mechanical properties. And he also writes specialized software to study such systems as mathematical graphs. So he's got a lot of Python background, and I can also attest to that because he has helped me all throughout grad school with some of my coding questions as well. So, and with that, I will now pass it over to you. So the floor is yours, Mahdi.
Thank you, Elisa, for that nice introduction. Appreciate it. And thanks, Pablo, for going over code of conduct. I'm really glad that you have a code of conduct, and I hope everyone tries to abide by that. I'm very glad, I'm very excited to talk about web scraping today. I hope you guys enjoy the talk as much as I enjoy talking about it. So let me share my screen, and then, so who can see my screen? I don't know how to work with you guys. Oh.
Yep, that's okay.
All right.
There we go.
Can you see my slides?
Yep, that looks great.
All right, cool. So let me actually, because I want to also take a look at the chat as I'm talking. So I'm going to move this to my external monitor for now. And let's start then. All right, so today I'm going to be talking about web scraping. So I'm glad that is also Elisa's favorite subject, or one of his favorite subjects, because I also happen to enjoy web scraping a lot, thinking about it. And I've talked to different people. A lot of people, want to be data scientists, and sometimes when they realize I'm a data scientist, they ask me the question of, do you know of a project that I can do? And I always start with web scraping. I say, hey, do this, that might be helpful. So it is not only a valuable skill to have, it's also very useful thing for personal reasons. Like if you are interested in doing, projects on your own, it's a very useful technique. So before starting, so this is a rough outline of what I'm going to be talking about. Now, just to reiterate, if you have a question, just speak up, don't wait. You could also use chat area to let me know if you have any questions. If you felt I'm going very fast, just stop me. Don't hesitate to raise any issues. And I hope you enjoy and learn about web scraping today. All right. So let's just start with the why part of it. Why web scraping is a valuable thing. Part of the reason goes back to business applications of it, which means you could potentially use web scraping to aggregate data. There are many websites on the web. Data is scattered. And if you manage to bring out some data from different websites together, you could potentially create a added value. And for some tasks, that added value is actually can translate to dollar. So you could have a business that uses this as web scraping or ideas of web scraping to generate revenue. I'm sure all of you have searched for airfare. If you want to go to a destination, you put it in the Google box, and then websites like Kayak and other websites, they search through all possible routes, and they tell you, hey, if you take this flight, it goes from your place to this destination. You might have 2 layovers, but it's actually much cheaper. So you might want to use that route or buy that ticket. The way these websites work, they're not responsible for setting up A routes, right? Or the airlines and airports, they're doing their own thing. So these websites, they search the web and they find all these data about airfares and air routes. And then they aggregate these together. So when you search, they say, all right, so this person is looking for going from A to B. And there are some constraints. For example, they don't want to fly direct because they want a cheaper fare. So given those constraints, they search the data throughout the web. And then they show the results. And that's basically how they make money, with the ads and you buying those tickets. The other example that I could give, and this is like very common these days because we have many stores. So if you're selling a product, you are selling it on Amazon, on eBay. Some countries have their own like a specific websites. And all these, like, you have a company selling that product on 10 different websites. And it's hard to manage how people react to your products. People write reviews, they give you stars. So you want to figure out, maybe like on Amazon, you're getting a lot of good reviews, but on eBay, you're not. So you want to figure out what's going on. Why eBay is not giving me good reviews, like people on eBay. So you can potentially scrape the data related to your product, put them together, and that gives you a sense of how you're doing on different platforms. Other examples that I go over quicker is finance, because on finance, you could imagine there's a huge different markets. Each market has their own stocks. If you've looked at the financial terms, they're usually very complex. A lot of things are happening at the same time at a fraction of a second. And if you have a specific portfolio or you care about a specific news, you might want to aggregate those data daily and then look at it and make your decisions, financial decisions based on it. And there are companies out there that do this. And also job search. If you search for jobs, there are many jobs that are being advertised on the web for different titles, different places. So you could aggregate all of those and have a better look at the job market to see how it looks like. And there are companies out there, as I said, making money off of these ideas. And you could have many, many other ideas. And the basis of all of this is aggregation of data. But also the other aspect, there's a personal aspect, as I said. You want to, especially nowadays, machine learning is very popular. rightly so, because it's very useful to help us making decisions in a more rigorous way. And a lot of people usually are, when they start, they might have ideas, but they don't know where to start. And a very good place to start is looking into your hobbies, the things you're interested in, and then using web scraping to collect some data that you care about and use that data as your test case. Learn machine learning models on that data. So you like here, I thought of 5 examples last night when I was putting this slides together. So one thing you could do is, let's say you have information, you're into movies like me, and you want to figure out which movies are going to win an award that you care about. So you could collect some data from internet about all the movies that have won an award in the last 50 years, let's say. Or you want to predict movie ticket sales. Which movie is going to sell a lot, which movie is not going to sell that much. You want to figure out that. And also it depends, this is a very interesting project, because it also depends on other things, like for example seasonality. Some movies are more appropriate for summers compared to winters. So figuring out these details, there's a lot of interesting questions you could ask in that problem. And if you're into secondhand books, you could aggregate some data from secondhand books and figure out where to buy them. A lot of people are after not a specific book, they're after a specific genre. So maybe you could aggregate this data and figure out the right book when it shows up. Or social networks have a lot of data that you could ask many questions, or policy making could be another example of this, that how people are thinking about what's the discourse about a topic, what kind of policies you could put in place to respond to those requests from or interest from the public. And all of these you could think of, whatever is your interest, you could think of your example. And that basically is motivation for web scraping. We need data, and the best way to get the data sometimes is data is not available out there. You have to make your own data. And that's like where the web scraping is important and is useful. So enough with the why. Let me go to how actually do web scraping, which is the more exciting part of it. So the point of web scraping is the data is already on the web, but the web is designed for human consumption. And if we want to put this data in a computer space and then run some analysis on it, the data that is already on the web page is not useful in the way that it's set up. So we have to take that data and then put that data into a structured way that we could use that data in our further analysis. And that's basically what web scraping is. But to actually being able to do web scraping, we have to know the language of the web. Because we're going to grab the data from the web, we have to know how the data is structured on the web. So HTML is the language of the web. If you want to understand how web works, you have to know how HTML works. That's why I want to dedicate a few short minutes about HTML if you're not familiar with. And get a sense of what HTML is. I'm not going to teach you what HTML is. I just want to show how it works. So HTML is a marked up language, which means you want to generate what we see in a text, right? A text could have a specific font. It could have a font size, like font size. It could be bold or not bold. It could have a different color, different background. All of these things are controlled using tags. Like here, you would see this is the paragraph. So there's a tag P, and it ends with a /P. And within this tag, your text is here. Right? And that basically tells HTML, hey, I'm starting a paragraph. And it knows what a paragraph is. So for images, you have its own tag. For videos, its own tag. All of these are tags, basically. And then a collection of tags become a web page. So let's do one step, make this one step more advanced. Now, let's say we want to change the font color and the background. How do we do it? So we modify the attributes of the tag. So here on the left, you would see I have the same p tag and then slash p tag, which was we had before. Now I'm saying, hey, this p tag has a style attribute, and then I can pass the font color and the background color to this and control how my paragraph looks like. Right? Easy. So you come up with a color, come up with a background color that you're interested in, you pass it on, it modifies it, and it looks like this. Now, not only you can control the effect on the text itself, as you could see, this background color spans all the way to the end. So there's no text here, but there's color. So you might say, well, I don't like this. I only want to span this background color up to here, up to the last character. How should I do it? Then use another tag. You say, hey, use the same p tags that we had before. Now instead, pass this style to another tag called a span. And that span basically limits where this background color can be applied. Hopefully this gives you an idea about how HTML looks like. So all the web page that you see, if you've never seen HTML before, it has a corresponding HTML code, which is made of all of these colors, background colors, and all the details you see on the screen. So if you want to take away one thing here is basically HTML is each piece of the web page is made of an HTML code. It has a tag, it has an attribute name, and then you can modify the attribute name using the attribute value. There's a text, and then there's a closing tag. And for web scraping, that's all we need. We need to be able to figure out what's the starting tag and what's the ending tag. And that's how we're going to get the data that we need. All right. So here's also another visualization that helps me to scrape web pages better. So each web page is made of those tags. So this body is a tag. And as you saw before, like this P is a tag, but it's underneath the body. So these tags could enclose other tags, as you will see. So it's nice to have this visualization in your mind when you're looking at web pages, because things are basically a parent and a child, and the child itself could be a parent of another child. And that would help us to traverse the web pages much easier when we're web scraping. I'm going to explain this in more details in the example that I chose. Right. And it's easy to get these tags on the web page. So you could just click, right-click on a text, click on the inspect, which is here, and it would show it to you. So as you can see, this Gary Oldman text here, when you click on inspect, it's an H4 tag, and it has a class, and the text is here. And the rest of the text is also have its own tags. If you've never seen it before, you could easily check on your browser using inspect. On different browsers, it could be inspect element or similar names, but all main browsers have this option. All right, so far so good. Is there any question, any concerns, anything that I need to explain again? If there's any concern, speak up, or put in the chat if you have any questions. So if there's not any question, I move on to an example that I want to basically scrape today, and then you can scrape with me if you have the code ready. So I want to go back to the idea I had about the box office. So I want to look at the historical data and see how much each movie sold on a day, and use some information about the movie. And for example, at the end, I want to create a machine learning model that would tell me how much I can expect to make off of a movie, given all the information that I have. Now for that, I need to know how much the past movies sold. And this is a nice website called The Numbers. And what they do, they're basically web scraping in a sense. But the way that they put the data together, you see this is for June 1st last year, and it would show you that this movie Aladdin sold, I think, 17 million on that day, and then this is the total gross value that they have, as the ticket sales, and they have this is the distributor, some other information about the year to date, like how they're beating the expectations or compared to yesterday, some details about like how much money they made. And then there's like a lot of other movies that you could see, for that date, all the movies in the US are listed here. And basically these movies are provided, as you could see here, these data are provided by the distributors themselves. So they put this together, and what I want to do as an example today is show to you how I can scrape the data from this web page and bring this data into Python, and then use that data for some other task, depending on how much time we have. I can show you more details. Now, let's use that tree visualization of the web page and figure out how should I extract this data from this web page. Now, first of all, why that tree visualization is useful? Because as you can see, there's a ton of other text on this web page that I don't need, right? These are not useful things for me. My goal is to just extract this. So for me, it would be very valuable if I find out what node in that tree contains this information. And I can go and say, hey, give me this node only. I'm not interested about this, like about other stuff in this web page. So let's figure out where this data is. So I'm going to click on this Aladdin, and you will see if you haven't seen this before. So I'm using Chrome, and it will show the inspect here. So if I click on the inspect, it opens this blob of text that I don't care about this part for now. So when you click on Aladdin, you see it's still highlighted. It has a corresponding HTML code here. Let's see if I can make this bigger. Yep. So as you could see, this is a tag, which stands for, this is for links. That's why when you can go and click on it, it goes to another page. So A stands for, I don't remember what A is called for actually, but it identifies the links. Right? And href basically gives you the reference or the destination that go to this web page. If you click on it, it goes to this web page. Or we're not interested in these links really. What we want to extract this Aladdin name from here, and then other information on that row. But let's go one step above. So this A is wrapped in B, right? And the B itself is wrapped in something called TD. These markers basically point us what's the parent. Now, if I close this down, you will see that when I click on this TD, it's showing the whole cell here, not just Aladdin, but the whole cell, not just the text. Sorry, here. Here. Yeah, so the whole cell is selected. So you could guess that TD is the data cell. That's the tag for a data cell. Now, if I go up one step, that's the cell to the left, and then I could go another one. That's the cell to the left. Let's go up another level. Now you see the whole row is selected, and the tag is called TR. That's a table row, right? Not surprising. So that's the whole data in there. Now let's go one step above again. There we go. So now you see T-body is a tag that contains all the information that I really care about. So if I go here and select T-body, you see it selects all the information, all the rows that I want. And it doesn't have any information that I'm not interested in. So if I want to do web scraping, I would say, hey, in this web page, give me T-body. Or you could go one step maybe above, get the T-head. Nothing changes really. And the table itself contains everything. So maybe we want to get the table because it has also the column names in table. The T-body itself doesn't have the the column names, but table itself has all the column names too. So if you imagine this is that tree, what we want to do is we got to go to Python, and then using Python, we would say, give me the tables in this web page. And then that table contains the information we need. So let's just start. If there's any question, feel free to jump in anytime. Don't let me talk all the time. Okay. So let's start with, is there any question? No, I think I heard something. All right. So I assume there's no questions. So first thing we need to do, like we know, Python doesn't know about that web page. So somehow we have to take in or import the contents of that page into Python. Now I'm using a Jupyter Notebook. If you want to follow and you don't have Jupyter Notebook, you could use your own Python editors. So requests gives us the option of pulling the data from a web page to Python. I'm going to show it to you how it works. So import request, and a request comes with Python, so everyone should have requests basically. Now I'm going to define a URL, which is the URL of this page that I'm going to extract the data from. So let's go here and pass the URL. It's actually quite easy to pull in the data from request. So I would say, sorry, not the URL. Requests.get this URL. And all it does is just goes to that website and gives me the whole HTML, the whole thing. So if you run this, it doesn't show it to you. It just tells you a response 200, which means it worked. So it's a thumbs up that everything worked. So let me define this as HTML. And as you saw, HTML is just a response. But within this HTML, there is an item called text. And if you print this, you should be able to see the whole HTML of the website. Now, of course, I don't care about the whole HTML. I just care about a specific part of it. But first, I pull in the whole text, and then I select the part that I'm interested in. So you see the whole data is here. The data that we're interested in is here. These are the rows that I talked about before. So you have TR tags, and within the TR tags, you have TD tags. And each TD has the information you care about. So this is like Hotel Mumbai, and it's from distributor Bleecker Street. So the information is here. We just have to somehow extract them from this website. Okay, so now the issue with this is, I am very sorry, one of my sculptures just exploded. Okay, so let's define this as HTML text. So now if you're familiar with Python, you'll know that you could see the type of this and say a string. And here's the why we need beautiful soup. What request does, it just pulls the whole HTML as a string. It's just the whole blob of text. It doesn't know what's TD, what's TR. It doesn't know about HTML. It just pulls the whole string. And that's why we need beautiful soup. Beautiful soup understands what's an HTML code and parses out this text into HTML. For that, we do, if you have installed beautiful soup before, you could import it. Hopefully I'm not misspelling beautiful soup. Yeah, hopefully this works. Yep. So I'm using beautiful soup. Let's see if I can find the version of this. So if you want to check it out later, it doesn't have version. Interesting. Okay. Maybe BS4 has its own version. Yeah, so I'm using 4.8.2. It might be different in other versions. That's the only reason I printed this out, so you could make sure you have the right version if you want to compare. And by the way, I think I'm gonna create a GitHub repo and post this on the GitHub. So if you want to follow from the GitHub repo, you could go to my GitHub profile and find this. Hopefully tonight I have the time to fix this and add some details and information too. All right, so far we had this HTML text, but it was a string. We want to convert it into HTML. So what we do, we say, all right, beautiful soup can do that for me. Beautiful soup dot. So we could say HTML dot text. So we pass this string, the blob of text, and then we tell the beautiful soup that please parse this out using HTML. And then I'm going to call this soup. So if you run this, beautiful soup goes through the text and figures out all those tags. It figures out, oh, this is a table, this is a H, this is a P. All of those are fine. So if you look into the soup, it looks the same, but actually now it differentiates between a meta, for example, and an LI environment or A environment. It knows about this, where they're located. And that's why we use it for JavaScript. Now, when we looked at here, we figured out all the data that we need is inside the table. So the easiest we could do is we could go to soup and say, hey, find all the table environments within this text. I'm going to create a table or tables. Let me create a bunch of new so I can go down. All right, so if I run this and then see how many tables it found, it might find more because there might be other tables on the table on the web page, but we don't care about them. We want only one of them. So let's run. All right, so there are two tables. Let's look at the first one. So this is a list of tables, basically. That's why I can pass an index and say, give me the first table, right? And the first table is just this part that says previous chart, next chart, which is basically here. You see, this is like where it found. So let me close this. Yeah, so this is one table on its own that we don't really care about. So we could ignore. So hopefully the second table that you found, it has the information we care about. Now, yes, look at here. So as you could see, this table has these tags inside it, which is like the first movie, and then there's a second movie, and the third movie. So all the movies are here up to the last row. Now, hopefully using this find all, you know where I'm going next. Now that I have the table one, I call this table with data. So this is the table that I actually care about. I don't care about the other table. And now I would say, hey, inside this table with data, I need all the rows. And all the rows have a tag called tr. So return me all the rows. Let's see if it actually can do that. Look at this. So what happened, it actually found all the tr tags and then put them in a list. So if I call these rows, then you could see row 0 is the header information. Rows 1 is the first movie that we have, Aladdin. Row 2 is the second movie. So far we managed to break this into rows. But at the end of the day, we really don't need this information, right? We need this text that is inside. So what we can do, for an example, I want to extract the text of this Godzilla example. I need this text, I need this text, I need this text, which is the gross value, right? So what I can do is I can loop over this row. So I would say for item in rows 2. So what it does, it goes, for loop goes through this one line at a time, right? Normal for loop. So one line at a time. And for each line, I would print item.get text. Hopefully I'm remembering correctly. So let me run this and see if it worked. No, it didn't work. All right. So get text. Oh, I see what happened. Yeah, I missed the part. Now you see this is a TR. It's not a list, it's just one item. So to get the TD values, you say within this row, find all TD objects. Yeah. So it's going to be a list of these rows. And for each of those, we can extract the text. Now let's see if it worked. There we go. It worked. So for this one, as you could see, it extracted the 2, extracted the 1, extracted the name of the movie, extracted the distributor, and so on and so forth. So now we figured out for one row, let's do it for all rows. So what we have to do, we have all rows here. We do it one row at a time. So we say for row in rows. Basically, I'm going to copy this down here. So for that specific row, find all the TD elements within that, which are the data. And for each of those items, print out the data we care about. Now, of course, this is going to be just a list of all the data that we care about. So maybe we want to regenerate that table. So we want to have each row in one list. So what you could do is I can modify this a little bit and say for row in rows, for item in row, find all TD. So give me all the data. Instead of printing, I'm gonna collect this item in a list comprehension. So I would say for each row, for each TD element, give me the text of that TD element and name this as a row parsed. That's basically the row that is parsed. So let's print the row parsed now so you would see if you're not familiar with comprehension, list comprehension, you would see what's the help. So now you would see each row, is in one list. And this is for the second movie, right? So each movie is now in one row. Now, probably you're familiar with the appending, so you could say, I need all the rows that are parsed. So you could say, after printing, please append that row to a list. What did I do? Rows parsed. Oh, here it should be an empty list. Yeah, so I created an empty list. I'm adding each row one by one to this list. If there's any question, don't forget to let me know. Okay, so now I have a list of all these rows, basically. Now you could choose here to save. You could, stop here and say, hey, I got my data, I'm done. Right. The other thing is you could put this in a pandas data frame if you're interested. So I will show you how easy now it is to put this in a pandas data frame. That is usually the first step to analyze the data. So you would do pd.pandas as pd and then p data frame, and you pass that list to, is it rows parsed? I guess I named it. There we go. So as you can see, all that data is not tabulated. Now there's a lot you could do. Still, first of all, this was for one day. So what if you want to get for multiple days? You usually don't care about a single day. You could go up here and write some functions or for loops that go back here. And this is, as you can see, this is for one day. Make a loop that goes over multiple days. And then for each of them, you could do this, the whole process from the start to finish. It's better to write functions so you could reproduce that easily. The other thing you could see is this data have this $sign, right? Which is a string, but these are numbers. So it's usually preferable to remove these. So you need to do some string post-processing or removing this one. So there are some other aspects that you could do, but as you saw, it is relatively easy once you figure out where the data is located in terms of HTML. It's very easy to go right there and tell the beautiful soup and request to give me the data that I'm interested in. So to retrade, we found out where the table was that has the information, and then we found it in request. Nice. All right. Cool. Is there any question about this? No questions? So I want to basically, I'm done with web scraping, because from now on, whatever web page you have, you pull that web page into the, a notebook or Python. You go find all the elements that you care about, and within those elements, loop through them and find what you're interested in. As easy as that. Okay, great. So let me go back to my slides now that we figured out how to do it. Now, let's talk about the if we should do it part. So one thing that I would like to talk about, and a lot of people are not maybe familiar with APIs, which is short for Application Programming Interface, is sometimes you don't have to web scrape. The websites themselves tell you, hey, here's the data. Here's how you get the data from me. You don't have to get it from their web page. You could get it from their databases. A lot of, especially larger websites like Wikipedia, Reddit, Twitter, all of these have their own APIs. So you don't have to go figure out within this HTML, I care about this tag and this other tag, and then doing a string manipulation, removing $signs, things like that. So using the API, you basically what you do, you send a request to API. You say, I need all the tweets that were happened yesterday from, let's say, US, and the device should be iPhone, for example. And then it would give you, in a batches of, I think, 100, it gives you the tweets, so you don't have to scrape them. But there's also limitations, right? With the API, you could only get the data for the past 2 weeks on Twitter, for example. So if you need older data, you have to scrape them. So there are other ways of getting data. The other thing that usually is you should search for it first is there are Python packages out there that you could use them to scrape. So instead of you figuring out how's the HTML formatted, you can use those packages to read the data into Python. And I know a few of the Python packages, like Wikipedia has its own Python package. So you don't need to even use Wikipedia API. It's much easier to use the Python package for it. The other thing that you should do if you decided to scrape, definitely don't send requests over and over and over again. So you could just wait a few seconds, for example, send a few requests, wait a few seconds, send a few more. That way it plays nicer. The other thing is you should be careful about the choice of what you do or what you can accomplish using a web package. Like I use request and beautiful soup that work on 99% of websites. My guess, 99%. But let's say your website the website that you're interested in has some JavaScript. So the data is being produced as part of a JavaScript, code. then Beautiful Soup wouldn't be useful anymore. You need to go towards other packages that let you scrape, and at the same time, they could also work with JavaScript generated data or content. So definitely, depending on the use case, you should use another package. Other aspect of this is the ethical and legal considerations. There are a few things I want to discuss. I don't want to scare you, but I would like to talk so you are aware of what are the limitations. Before scraping any website, make sure you read the terms of service so you know what you can and what you cannot do. Sometimes you read, like, for example, I got this, sorry, from New York Times. So New York Times has a section in their terms of service called prohibited use of services. And in explicit, it says you can't scrape or use any robots to gather data from New York Times. Some other websites have the license and site access. So they might say if it's for personal use, it's free. You are free to extract the data and scrape. But if you want to use it for commercial purposes, you have to get a permission. Also, the other aspect that is becoming more and more important is scraping private information. Private information sometimes is like name, address, that you could locate a person from that. Sometimes it's like personally identifiable information, which is like phone numbers, that if someone gives you a phone number, you can't necessarily connect it to a person, right? But if you have other information and you put them together, you say, I got the phone number from website A, name from website B, and then I connect them together, then you could breach some protocols, especially like with the new policies, especially Europe. It's illegal to scrape any identifiable information from any citizens of Europe, any country in Europe or European Union, basically. And California has its own version, and gradually probably other states will have that too. The other thing is copyrighted materials. For copyrighted materials, it doesn't mean you can't scrape copyrighted materials. It means you have to be careful about the usage. Usually, for fair use, for example, for academic purposes, or you want to do a personal projects, it's often okay to scrape copyrighted materials. But if you, let's say, you take the data and then you create a poster out of it, and then you send the poster on web and you make money, then it wouldn't be okay in those cases. And as I said before, it's good that if you, for our example, if you're going to pull the data of 50 years of box office, then after, I don't know, maybe for every 50 days that you scrape, wait a few seconds, and then scrape 50 more pages. That way the server would not be loaded with requests, and it can serve everybody. So these are two resources that I've said before, and they're very useful for web scraping. There's a lot of ground that I couldn't cover in this short amount of time. So especially I like this repo from Brian Keegan, who is a professor at, I think, Colorado Boulder, if I'm not mistaken, and my memory is not failing me. And it's a GitHub repo that you could go and check it out. It has lots of interesting examples of how to extract data from different types of web pages. Also, it teaches Selenium, which is equivalent of Beautiful Soup, but it is more, in a sense, advanced. So you could use that as well. So with that, thank you so much for listening to me and hearing some questions on the chat.
There are some questions in the chat.
Yeah, awesome. All right, let's see. 6 questions on the chat. All right. Wow, web scraping magic from Melissa. I'm happy that you saw the magic. Okay, so question is, how do you know if a website has an accessible API? Great question. So usually if you, I think I started, but if you go on example, so I want to go, all the websites for web scraping, you should always scroll all the way down because that's where the information about these things are. So for API, it's usually called developers, right? It would show that developers have a special version. So I don't know if I can share my screen again to show you for at least for Twitter. All right. So let me share my screen. So this is my Twitter page. If you scroll here on more, there's developers, right? If you click on developers, it has all the information you need about the API. If you go to, usually either say developers or API on the web page that you could search. So that's roughly a little bit manual. You have to go through it to see if it makes sense or not, or if it does an API or not. Also, I think for
It's
all
like
the APIs,
sorry.
go ahead.
Yes, it's like a case by case
Mhm.
situation. You're gonna have to kind of like investigate a bit if your website has an API already.
Yeah, exactly. Other thing
Yeah.
you could do is usually useful. You could do, let's say, I didn't know if Twitter has an API. So you could do Twitter pip Python and see if there's a package in Python for it. And there's usually one for anything you could imagine. I don't know if Reddit has one, but it doesn't seem to have one. What about Wikipedia? Yeah, Wikipedia. So you on PyPy usually you could find packages that would help you for a specific website. So you don't have to repeat your steps like every time I find out the web page. All right, second is the next question. Can I use an API or scraping package to extract my own data, say my YouTube history or commutes? Very nice question. So it depends on where the data is. So let's see, for YouTube, I remember it had a package that you could extract some. YouTube Python. Yep. So you could use these for a specific channel, you could get the information. Especially like there's a lot of cooler stuff for YouTube videos that you could extract, like the video, as you know, when you're playing video, it automatically suggests the quality. And those are basically coming from your bandwidth, where you're located, and you could access all those information and see how the processing for YouTube is working. So for the commutes, it depends on the app that you have. Like Google Maps, I guess it gives you the data for your own user or your own account, but I don't think you can scrape for other people's account. I think so. I'm not sure, but I'm pretty sure you could for Google Maps, you could get it. And I'm sure other maps like Open Maps have their own APIs. So you could use those as well. So next question, is there a way to bypass for loops to traverse the HTML tree? Just thinking on cases like trying to scrape Twitter, which massive amounts of data per unit of time. Very good question. So in cases like Twitter, which is basically data is flowing and is streaming, it's much better to use API for the very reason that Pablo is saying, because when you are scraping, the second that you're scraping, thousands of tweets are actually added to Twitter, right, within that short period of time. So how do you manage to keep all of those tweets in your, so you have to have a for loop on all the time to go through all the web pages. And the other thing you could see is if you go on Twitter, I think mine is open so I can show it. So if you go down, not all the tweets are actually loaded. Once you reach the end, it loads new tweets. So when you read that Twitter webpage into Python, it actually doesn't have all the tweets, not all the tweets, right? So you have to, I don't know, come back here and load this. Hey, so scroll over and over and over again so you have like enough tweets. That's not really feasible. So it's better to use the API and say, hey, use this API and you know, give me all the tweets that happened between these two time frames, and that way you could extract all the tweets at the same time. Yeah, next question, Jason. For the EU, I think GDPR is the newish. Yes, exactly. I meant GDPR. I sort of was I wasn't sure if I'm remembering the acronym right, so I didn't say it, but it is GDPR. So you can scrape any information, personal information of UN citizens as part of the GDPR. And California has its own version of GDPR, which even companies in California have been like very active in making sure they're not exposing any personal information. I hope
Cool.
these are all great questions. Thank you.
Yeah, thank you so much, Mahdi. That was an amazing presentation.
Of
It's
course, my
actually,
pleasure.
I realize now that it's like way easier than I thought initially,
Yeah,
because here's basically how to just traverse a tree.
exactly.
And
A
with
lot
the
of times
packages, it seems to be easier.
I've seen that people have these they think web scraping is hard, but when you actually see it, they say it's not really that hard. You have to go, as you said, traverse a tree, which is a very logical thing once you visualize it.
Right. Yeah, so if there's no other questions, I just want to thank everyone for attending to this meeting. We don't have speaker for the next month just yet, or for future months. So if anyone wants to jump in and present, that will be amazing. Maybe from next month or other months, and can be any topic. So let us know. Otherwise, I don't know if Alisa has something to say.
I don't think I have anything to add. I think you covered everything. Other than like, I'll just want to say again that it was a fantastic talk, and we were so excited to see all of that amazing stuff and tips and things like that. So thank you so much, Maddie, for donating your
Oh,
time
my
and being so
pleasure.
generous.
Thank you for having me and inviting me. It was my pleasure.
So great.
Super cool. Okay, good night.
Have a good night, everyone.
Thank you so much, Maddie. Have a good one.
Of course. You too.
Bye,
Bye-bye.
everybody.
Bye-bye.
Thank you for
Bye-bye.
joining.